Hi, in this video we will learn about a new product for vectors with three components, vectors from R3. Let me start with the definition right away. Definition. Let two vectors U, which has three components, and V, again same, coming from R2 R3, be vectors in R3. Then the cross product which we denote by U cross V is a vector in R3 given by, okay, what is the recipe? What is the formula for that? U cross V has this form that, first of all, it's a vector in R3, so we have three components for that. The first component is U2 V3 minus U3 V2. The second component is U3 V1 minus U1 V3. And the third one is U1 V2 minus U2 V1. Well, I know the formula is strange and it's not easy in the first look to keep in mind. That's why we will have a pattern for that that will help us to learn and keep this in mind. To keep the pattern in mind, I need you to remember, maybe from somewhere, that when you have a 2 by 2 matrix, meaning that there are 4 entries A, B, C, D, then when someone says determinant of that 2 by 2 matrix, it means that you multiply the entries on the main diagonal A times D, and then multiply the entries on off diagonal B, C, then subtract. AD minus BC is determinant. So why this is important? Well, when someone tries to find U cross V, you can do this thing. Put entries of, or the components of U in the first row, and components of V in the second one. Then the cross product is given by this method. For the first entry, you forget or ignore the first column. The remaining is a 2 by 2 matrix. Find the determinant of that. Determinant of U2, U3, V2, V3. That's the first entry. The third entry goes also similarly. So you ignore the third column. The remaining is a 2 by 2 matrix. Find determinant of that. U1, U2, V1, V2. And for the middle one, also you ignore the second column, and the remaining is basically determinant of, you see, this is the first column of that matrix, U1, U3, V1, V3, But in the middle entry, in that second entry, you have to multiply that determinant by a negative sign. And that is how you find. Now, if you let me write this down, you see that the main diagonal entries is u2 v3 minus off diagonal is u3 v2. And then here we have minus u1 v3 minus v1 u3 and u1 v2 minus v1 u2. That's how you get the above formula. So only knowing the determinant of 2 by 2 matrices, that gives you a nice way to memorize how this works. Before I do an example, let me write a remark here that there is very deep difference. There are differences between dot product and cross product. And let me start the remark like this. Unlike the dot product, unlike the dot product, cross product, there are two big differences. First of all, cross product is only defined for vectors from R3. We can only apply cross product for the vectors with 3 components. And the second difference is that the cross product of 2 vectors is again a vector, not a number. For dot product, you had 2 vectors, product would give you a number. Here you find a vector. And that's the difference, 2 main differences between these 2 products. Let us do some examples before we go ahead and add a little bit more to this example. We'll find the cross product, find the given cross products. Well, the first one is 1, 2, 0 cross 2, negative 1, 3. And the second one is I, vector I plus j minus k cross 2I minus 3k. Okay, let's see how this works. Okay, so we know that we have to put the vector entry. The first one goes to the 1, 2, 0, and then 2, negative 1, 3. Now, the product is going to be a vector with 3 entries. What we do for the first one, ignore the first column. Then the determinant of the remaining one, which is a 2 by 2 matrix. Let me just write it like that. We'll come back to that, to come back and compute that piece. Okay, that's the first. For the second one, we ignore the second column, cover the second column, then find the determinant of remaining 2 by 2 matrix. 1, 0, 2, 3. Well, remember that in the main formula, we have a negative sign in front of the second entry or second component. And that being done, now it's turn for the third entry, third component. You ignore the third column and find the determinant of 2 by 2. 1, 2, 2, negative 1. Very nice. So we have set it up. Let me just put this a little bit lower. We have set it up the components. Now we have to compute. Determinant of 2 by 2 matrix means that you multiply diagonal entries 2 times 3 minus negative 1 times 0. 1 times 3, first these ones, minus 0 times 2, and 1 times negative 1 minus 2 times 2. This gives us, well, 6 minus 0 is 6. This is 1 times 3 is 3 minus 0 is 3. And there's a negative 1, so it's negative 3. And the last one is negative 1 minus 4, which gives me negative 5. And that's the dot cross product of those two vectors. Okay, now let's do example 2. The first thing to do is to write the vectors in the 3 component form. So it will be 1, 1, negative 1 for the first one, cross. 2 is the coefficient of I. There is no j. That means that the coefficient of j is 0, and then negative 3. Now, the cross product is going to be a vector, 3 by 3 vector. And to find its components, we put this first vector in the first row, the second vector in the second row. To find the first component, we cover the first column. Then the remaining is, let me do black here. So the remaining is a 2 by 2 matrix, and we are supposed to find its determinant. For the second entry, we cover the second column, the remaining matrix, 2 by 2 matrix, 1, negative 1, 2, negative 3. And don't forget a negative sign in the second component. For the third one, we cover the third column and find the determinant of 1, the remaining 2 by 2 matrix. Okay, now determinant of 2 by 2 matrix, multiply diagonal entries minus off diagonal entries. This one is 1 times negative 3 minus 2 times negative 1. And that one is 1 times 0 minus 2 times 1. And this way we find negative 3 first component. Look at this one. This is negative 3 plus 2. That's negative 1. There's a negative sign outside. That will be 1. And then there's a negative 2. Well, you can write this back in terms of ijk. I'd like to do it here. And that's what we have. Okay. Let me finish the video by the properties of cross products. So, cross product. First thing is that cross product is not commutative, meaning that if you multiply a vector u to v and then you switch the order and you cross product, you are not going to get the same vector, but instead you will get a negative sign there. Okay, so if you change the order of vectors of the cross product, you get a negative sign. The second thing is that, well, cross product and sum of vectors, these two work nicely together. It means that, well, you can expand cross product on the vector addition. The important thing here is that you have to keep the order. You see the u is multiplying from the left, and here you still keep that order. The third thing is that how does cross product and scalar product work. So in this case, you can bring in scalar product first, multiply to the only one of these vectors, and then cross product. And this can be either of these two guys. That will give you the same thing. There are two more things. Well, if you cross product a vector to itself or any multiple of itself, you will get 0 vector. And well, obviously, if you cross product 0 vector by any given vector, you will get 0 vector back. So these are the main properties that you have to keep in mind. And well, that's the end of the video. You have to know how to find the cross product, and you have to be able to carry out the computations needed for that.